Today we're going to start looking at smooth muscles and other muscle types. The first one that we look at will be smooth muscle fibers. Smooth muscle cells, we're going to look at some of the shape. They're very long compared to some of the others, tapered ends, and they lack striations, which we had looked at earlier in the year when we looked at different types of cells. They're relatively undeveloped sarcoplasmic reticulum, the endoplasmic reticulum of a muscle cell. Actin and myosin inside of a smooth muscle extend the entire length of the cell, and they're organized a little bit differently than skeletal muscle, and that's why there aren't any striations. Multi-unit, many unit smooth muscle, visceral muscles are two types. So in a multi-unit smooth muscle, the examples here would be blood vessels, the iris of your eye that regulates the opening of your pupil. In those, the fibers occur separately rather than laid down in sheets. So they run individually. Multi-unit, many individuals. Visceral smooth muscle, like your organs, are going to actually be laid down more in a sheet-like manner. And then, because they're arranged like that, peristalsis, many of your internal organs have to move food, and peristalsis is kind of this rhythmic squeezing of organs. So when you chew and your esophagus has to move food down to your stomach, it basically will squeeze, squeeze, squeeze and push the food down, and that would be peristalsis. And that works because of these sheet-like arrangement of visceral muscles. Smooth muscles, your myosin to actin binding is similar for your skeletal also. Acetylcholine, remember we said was very important for muscle contraction, and norepinephrine are both used to stimulate muscle contraction or inhibit muscle contraction, depending on where it is targeted. Hormones can also be involved with stimulating or inhibiting contraction, and the main one that you can think of there is actual labor contractions are regulated by hormones. Smooth muscle is a little bit slower to contract and relax than your skeletal muscle, but it can stay contracted for longer periods of time. So with that contrast, basically they use about the same amount of ATP. Smooth muscle can contract slower, but it lasts a longer period of time, so it needs quite a bit of ATP. Smooth muscle also regulates or changes its length without becoming very tight, which is very important for organs like the stomach, even your esophagus, organs that need to stretch. I don't want my esophagus to only stretch so far and then get tight. Otherwise, food can get trapped. Same thing with your stomach. When you eat a very big meal, your stomach expands and it feels full, but it's still not going to be so tight that something horribly could go wrong if it did that. Cardiac muscle deals specifically with your heart, so that's the only place that you will find cardiac muscle. It's branching and it's striated, and here again we have looked at this before. Mechanism of contraction in cardiac muscle is pretty much the same as skeletal muscle, but there's a couple of differences. Cardiac muscle has little transverse tubules that give extra calcium. Your heart is one of your, if not the strongest muscle in your body. It beats continually. It's used constantly. So extra calcium, remember calcium is very important in muscle contraction. So then your heart can contract for longer periods of time. Cardiac muscle is also self-exciting and it's rhythmic. So if you've ever seen videos, you can take a heart cell that's beating and another heart cell that might be beating faster, you put them together and they will end up in the same rhythm, beating at the same time, and it's very interesting to see. So cardiac muscle, self-exciting, very, very rhythmic, because that is the job of your cardiac muscle. There are complex junctions, those intercalated discs. They're a darker color that you can see under the microscope. They join the cells and they transmit the contraction from one cell to the other, and that junction helps carry that rhythm or that beat from one cell to the other. And it's also important because of the rapid transmission that's needed in your heart. So at the top of your heart you have the SA node that stimulates or sends the electrical impulse for your heart to beat. That transmission through your heart has to be very, very rapid. So here's kind of a sum up of all your muscles, and this table's in your book. So skeletal, smooth, cardiac. I'm not going to read through all of this, but it's a very good tool for comparing the different types of muscles. And skeletal muscle contractions, a little bit more here. Origin and insertion, we have looked at this. Your worksheet dealt with this. The immovable end of a muscle is the origin. And usually your origin is on a different bone than your insertion, which you should have noticed. So for example, if I'm looking at my bicep again, just because that's an easy one to look at, the origin is going to be on my humerus up at the top. And notice that when it contracts, it lifts my lower arm. So obviously the insertion is not on the same bone, or it would somehow move the same bone. So the origin is the immovable end, and the movable end is the insertion. And the insertion end is always pulled towards the origin. So you can really see that, you know, when you start doing things. Okay, if I curl my hand up, obviously these muscles are pulling it up. So my origin is going to be up here. If I flex my leg, obviously the origin is going to be towards the top of my leg. The insertion is going to be on the bottom because it pulls my lower leg up. So here you can actually see, like I said, the origin's at the top. Your insertion is on your lower arm. It occurs on the radius for the main part, and that's what pulls the bottom part of your arm up. When that happens, one muscle doesn't do everything ever. So we look at this in a group of muscles. So the muscle that does the majority of the work, so if I'm looking at my biceps again, that would be my prime mover. It's the agonist, it's the one that does the prime movement, it's the primary muscle that's working. Helper muscles are going to be your synergists. So my deltoid helps a little bit. My brachioradialis might help a little bit. Those would be synergists. They help with the movement. Antagonists are the opposing muscles. So if my biceps the prime mover, my triceps is the antagonist. It's going to have the opposite motion. And the relationship between all of those muscles depend on the action that you're doing. The role can change depending on, am I lifting my arm straight, am I kind of curving it, what am I doing with it? Different muscles will be involved. And that's where we'll stop. Next time we'll actually start looking at specific muscles, and the following lectures will be very important because I will give you helpful hints on what muscles you actually need to know. So please make sure that you watch all of them.